Excellent. Right. Well, for those of you that don't know me, I'm Roy Bartle, and I sit here in the Department of Engineering at Lews Castle College in the sunny Outer Hebrides, where we ostensibly spearhead the developments in seaweed drying. And I hope to speak to you just for 5 minutes about three things. Firstly, to ask the question, what is optimal seaweed drying? Secondly, to give you a very brief overview of what we are doing to advance seaweed drying. And thirdly, to look in more detail at one aspect of the work that we've done over the past few months. So firstly then, optimal seaweed drying. And one wonders whether the word optimal perhaps is a misnomer. Because if you're a seaweed producer, then you will score the success of your seaweed drying method on several factors. It could be the nutritional characteristics of the end product, how that product looks, how quickly it dries, how sustainable the process is, how much you have to spend to obtain the equipment, scalability. So if you're a seaweed producer and you start off producing half a ton a day, and over the course of some months end up producing several tons a day, will you find that you need to buy a new piece of equipment, or will your seaweed drying system work? And there are two things associated with this. The first thing that we ought to note is that there is no perfect solution. Different solutions have different advantages and disadvantages. And that's related to the second thing, which is that different producers place different emphases on different aspects of any kind of drying system. So for example, you might be looking at the high end of the market and therefore product aesthetics are very important, or you might be just starting out and not have a lot of money to spend on initial expenditure. And so a low initial system price is very important. The reason I mention all of this is just to say that our philosophy in the drying sector of the SW Grow program is not to produce blanket statements of what is right and what is wrong, but rather to elucidate different aspects of seaweed drying, to understand them better, and then to convey what we've learnt to producers and others in the community so that they in turn can make informed decisions when it comes to seaweed drying. Secondly, I thought to give you a very, very brief overview of what we in Lews Castle College UHI are doing to advance seaweed drying. And broadly speaking, there are two strands to our work. There is a seaweed drying fundamentals strand, which is looking in detail at the different aspects that affect the drying of seaweed and indeed of other materials. And then there's also an energy systems for drying aspect, which takes the drying system now instead as a black box and looks at the energy systems that are required around it. For example, how can seaweed drying be incorporated into a renewable energy system using wind or solar? Or, as we have a pilot in the Faroes with Tari seaweed, a hydro turbine system. Now, we've already published earlier in the year at the Arctic Frontiers Conference in Tromsø some work on the energy systems side. So I thought it'd be more interesting for you if we focused in the remainder of this presentation on some work we've done on the left-hand side in seaweed drying fundamentals, and in particular in natural convection drying kinetics. Now, these are the two seaweed species that we have been looking at, Alaria esculenta and Palmeria palmata, and you may well know them by other names. We asked two questions. The first question is, how does air temperature affect drying time in natural convective drying? And the answer is, if you look at these two graphs, with time on the x-axis in log scale and moisture ratio on the y-axis, where a moisture ratio of 1 is wet seaweed, as it were, as it comes out of the sea, and 0 is fully dry. What we found was that for both species, increasing the air temperature, the drying temperature from 40 degrees to 70 degrees, decreased the drying time in both species to by about 60%, which is quite considerable. Now, speaking to people in the seaweed industry, anecdotally, there seems to be this assumption that increasing drying temperature has an adverse or disadvantageous effect on the nutritional properties of seaweed. Now, that's not something that we have been able to address directly, but the vast bulk of literature that's been published shows either no effect on drying temperature on seaweed nutrition, or indeed a positive effect. That is, that increasing the drying temperature actually helps preserve some of the nutrients in the seaweed. And the suggestion is that because the drying time is shorter, so there's less opportunity for nutrition to leach out. That, of course, only works up to a certain level. If you start burning the substance, then you lose all of the nutritional properties. The second question we asked was, how dry does the dry seaweed need to be when stored? Because it's certainly the case that with some foodstuffs like grain, the material does not need to be fully dried. And drying something more than is necessary wastes energy, which is a disadvantage to the environment, and it costs money. Now, the magic figure is a water activity of under 0.61. We don't have time to define what water activity is, but just remember this figure. Water activity of under 6.61 inhibits microbial growth in any foodstuff. And what we found was for both our seaweeds, if you see these graphs show water activity on the x-axis and a weight ratio on the y-axis, that there are almost no points where water activity is not totally dry, so it's not 0 on the y-axis, but is under 0.61 on the x-axis. And in layman's terms, what this means is that producers need to make sure that when they are drying their seaweed, that the seaweed is fully dry. And for our purposes, we define fully dry as if the sample declined in weight by less than 10 to the minus 5 grams per minute for 5 minutes. In other words, you need to be sure that there is no change in weight with time for the seaweed to be totally dry. Otherwise, the seaweed will start to spoil when it's stored. Now, that has taken up all the time. For more information, you might like to look at our papers or drop me an email, or perhaps you have questions that you might intend to raise over the next few hours. Thank you very much.